will this element be? Which one? Bromine, okay. And it's a neutral. Okay, so that means we have 35 protons because it's neutral. These have to equal. Okay. How about this one? This is nitrogen 2 minus. What kind of atom is it? Good, anion. And then how many protons does nitrogen have? 7. How many electrons will nitrogen 2 minus have? Good. Okay. And then, what element is this? Okay, it's a cation. We got more protons and neutrons. Aluminum. And then, -1, +1. We don't need to put the 1, so we're just going to put plus. All right, and that's all done. Okay, questions on that? Okay. Oh, no. All right, let me go over my slides. We are going to start on, well, I guess let's look at this schedule first. Oh, we're not doing it again. Excuse me. I thought I knew this. Just a second, we're looking at the wrong slide because I updated my slide. Oh, now I really did the wrong slide. What's going on? Maybe it is. Okay, so let's look at our map. We are here Thursday. We're going to start chapter 3. Lab 2, the last day you can turn it in is in a week. So make sure if you haven't already turned in lab 2, turn it in. And remember, if you turn it in before the deadline, then I can grade it and then you can correct it and resubmit. So don't wait till the last day or you won't be able to correct anything. Then next Friday we'll do lab 3. This is still not the most exciting lab, so make sure you bring your pre-lab. It's a little bit long and tedious, so you want to make sure that you have your pre-lab so you can get right in the lab and get the lab done. And then this is the day, October 10th is when Alex chapter 3 is due, and then we'll have a review. We'll have fall break and then chapter 3 is. Yeah, Alex chapter 3 assignment is due on October 10th. Okay, questions about the next couple weeks? Okay, very good. Here we go. Here's our notes. These are a little bit long, but hopefully we'll get through them pretty fast. So we're talking about different types of bonding and the octet rule. So we're going to try to predict if a compound is ionic or covalent. And then we're going to talk about properties of ionic compounds. Okay, so I have these different elements. Is this right? Are we on the right spot? Yeah, okay. How many valence electrons does, do we have? Yeah, rubidium have. I think it's in one of the first 2 columns. Okay, so if it has 1 valence electron, we're going to start drawing this Lewis dot diagram. So I just write the element, and then somewhere around here I'm going to represent the valence electrons. Yep, so think of this like a box, and I can fit 2 electrons on each side of the box. So if I just have 1, I'm just going to pick one side. It doesn't like over there, so I'm going to draw it over here. So now this is a Lewis dot structure. Rubidium has 1 valence electron. This is going to help us predict bonding. All right, how about Ge, germanium? How many valence electrons? 4. Good, 4. So there's a few different ways to do this. I like to draw 4 all by themselves because this helps us understand. So things with 4 valence electrons can bond to 4 different things. So that's why I draw it like this. Okay. All right, how about iodine? 7. So then we're going to put almost full. 2, 4, 6, 7 valence electrons. How about krypton? So this will just be full. Okay, normally we don't draw the box. I just don't know why I just decided to draw a box on 3 of them. So normally we don't have the box. This is our Lewis dot diagram for krypton. Okay. All right. Hopefully that's pretty straightforward. All right, so the octet rule is the S and P block elements want to fill their outer shell, their outer valence shell with 8 electrons. So octet, that's where 8 comes from, or that's where the octet comes from. And atoms are going to gain or lose electrons until they get that ideal 8 electrons. If you have 8 electrons in your outermost orbital, that's a lower energy level, and that's a trend in chemistry. If it has a lower energy, that's going to be more favorable, and it'll try to get to 8 electrons. So do you remember, where is the S and the P block? Do you guys remember? We talked about this once. Anyone remember? Sorry? So, kind of, yeah. Yep, so these 2 columns are the S block, and that block over there is the P block. Yep, and I'll pull that up. So here is our S block. This is where our S electrons are filling, and this is where our P electrons are filling. So that's our S and our P block.
3, 4, 5, 6.
So we've got our S and our P block. So these will always try to get 8 electrons, except for helium. Helium's an exception. How many electrons does helium have?
2.
2. So it can only ever have 2 electrons because it's really small. So helium is an exception to the octet rule.
Can you go back for just a second?
This one?
The other one.
This one? Okay. Yeah. Okay, so we've got our S and P block. So let's go ahead and try some of these. So we've got lithium, sodium, potassium, got group 1. How many valence electrons do they have? So first group, how many valence electrons?
1.
Good, 1. And that's the outer ring. So 1 on the outer ring, 1 valence electron. Okay, are they going to, how many electrons would it take to get to 8?
7.
So are they going to gain 7, or are they going to lose 1? We can either gain or lose. They're going to lose 1. Lose 1 electron to achieve an octet. And if you give away 1 electron, what's the charge going to be?
No, +1.
Yep, good. It'll be +1. +1 charge. So does that make sense how I reasoned through that?
Oh.
Okay, we're ready to, how about, oh, slow.
Why does it have a positive charge?
Good question. So we started at a neutral. So lithium, let's look at lithium. It has 3 electrons and 3 protons. And then it wants an octet. It wants a full shell. So it's going to give away an electron. It gave away a negative charge, but it still has 3 protons. So that's where that positive, just imbalance, charge imbalance. Good question. Okay. Group 15. So if we count over 1, 2, 15, this is nitrogen, phosphorus, and arsenic. So how many valence electrons does atoms in nitrogen's column have?
5.
Okay, good. 5 valence electrons. Are they going to lose all of the electrons in their outer ring, so lose 5, or are they going to gain 3?
Gain 3.
Good, they're going to gain 3. And then if they get 3 more electrons, they're going to have an octet. That's what's driving this, is that we want 8 electrons in our outer shell. So if we gain 3 electrons, what will the charge be? Good, it'll have a -3 charge. Good, and then when we write that, it'll be 3 minutes. Okay, good.
What if you have 4 valence electrons?
Good question. So carbon, generally we don't find it as an ion.
Okay.
Yep, because it could do either, right? It could gain 4 or it could lose 4. So it's kind of in between, yeah.
What about the other one that's not column?
They don't really. No, we probably won't. They won't come up. I don't think. Because they could go either way. They could be a -4 charge or they could be a +4, because they're right in the middle. Okay, how about 14? So this is carbon, silicon, germanium. Oh, this is what your question was. These have 4 valence electrons. They need to either gain or lose. Oops. Or lose 4. Okay. So if they gain 4 electrons, it'll be -4. If they lose 4 electrons, there will be a +4 charge. So they're kind of in the middle. We probably won't see this very often. That's just a really high charge on a carbon. That's not very stable. Okay. How about group 18? So this is the last column.
Helium.
Yep. Helium has a full shell. Helium has 2 valence electrons. Good. How about the rest of them? How many valence electrons? Good. They have 8. I don't know what all these links mean. Valence electrons. This is an octet. Okay. So they don't form ions. So things that's why these noble gases are very inert. They don't react, they don't form compounds. Because they have that full shell, that's a really low energy. They don't want to gain or lose electrons. Okay. They're going to be happy how they are. They don't want to share. Okay. All right, and I showed you this in the last slides because I thought it was supposed to go here or there, but it should go here. Okay, here my column. So this is the trends. So column 1 forms a +1 charge. Column 2 generally forms a +2 charge. There's a few transition metals that always form the same charge. So I think you might have to remember some of these. I can't remember from last year. Silver is always +1. Okay. Cadmium and zinc are always +2. Gallium and aluminum are always +3. They're in that 3rd column. And then from nitrogen starts forming ions, 3-. Oxygen's column forms 2-. Fluorine's column forms a 1- charge. They just need 1 more electron. And then the last column, they don't form ions. And all of these charges are driven by that octet. It's more stable to have a full orbital of electrons. Questions on that? And then the transition metals have all sorts of charges. They can be +1, +3, +4, depending on what element it is. So these are trends that we can memorize. Those ones we have to figure out based on the compound. And then the carbon, silicon, boron, they're kind of also usually don't form charges.
Wait, do the center ones have valence electrons?
Like the D shell, yes, you can count their valence electrons. Yeah. But because we're getting into the D shell, you have to start counting the outermost electrons.
Okay.
So that first level, like scandium, titanium, vanadium,
Scandium.
yeah, those have a d orbital. That's the 3d energy level.
Okay.
But if you count down 1, 2, 3, it's actually on the 4th level, so it gets kind of weird which electrons you're counting as outer electrons and which ones are inner electrons.
Okay.
So if you take a higher level chemistry class, you'll talk about that.
Alright.
But we mostly stay above the D shell. Yes, so chemistry can get more complicated, but we try to stay out of the complicated stuff in this class, mostly. All right. The next thing that we want to talk about is isoelectronic. So iso means the same, stays the same. Can you think of any other places you've heard of
Isolated.
isolated? Okay, stays the same. Okay. Have you guys ever used an isosceles triangle in math?
Yep.
So that means all the sides are the same. Okay. Oh, two sides. Two sides are the same, I guess, in isosceles. So iso just means that you have the same. So isoelectronic means you have the same number of electrons. So if we look at calcium 2+, it's in that second column. It wants to give away 2 electrons instead of gain 8 electrons. So calcium is isoelectronic with potassium because potassium. Let's go back. How many electrons does calcium 2+ have?
1.
So it has 20 protons.
Plus 2.
It has 18 electrons. And then potassium itself has 19 electrons. But we lose one, so it also has 18 electrons. Argon, neutral argon has 18 electrons. Chlorine has 17 electrons, but chlorine minus has an extra electron, so it has 18 electrons. And then sulfur has 16 electrons normally, but if it has 2 extra electrons, it also has 18 electrons. So all of these are isoelectronic. They all have the same number of electrons.
Does it matter what the charge is on it?
Yes, it does. Because calcium 1+ wouldn't have 18 electrons. Is that what you mean, or what do you mean?
Like, can it be any element and you just...
Yeah. Yep, and you just work your way back. Yes. Yep. Yep, so if I picked like selenium and I did like 30, then, or something like that. Yeah, 30+, something like that. Yep. That is okay. Okay, questions here? Okay. There is one test question that asks you for isoelectronics, so make sure you practice that. And it's not too hard, you just figure out which one it's asking you about and then work your way either away from it or back the other way. Okay, so I want you to do one of these. Find 2 cations and 2 anions that have the same number of electrons as maybe the krypton. So find 2 cations and 2 anions. If you have extra time, you can do the manual. Okay, let's start this together. If you haven't already. So krypton, let's put that one in the middle. How many electrons does krypton have?
36.
Okay, 36. So isoelectronic, we need to find an element, 2 cations and 2 anions that also have 36 elements. So did somebody find a cation? What cation has the same number of electrons?
The SR negative 2. Or plus 10. Sorry.
Okay, 2 plus. Okay, so strontium, Sr has 38 protons. So if we take 2 of those electrons away, we will also have 36 electrons. Okay, isoelectronic with rubidium. And what charge? Rubidium plus. Okay, so rubidium plus is usually 37 electrons, but if we take one away, then it has 36. Good. Okay, how about, so these are cations, they have plus charges. How about anions? Okay. Bromine, what charge should we put on bromine? Good, negative. So bromine wants to gain 1 electron to have 36 electrons. Okay. One more. Selenium. And what should our charge be? 2 minus. And so this would be, it would also have 36 electrons. I'll put electrons on here. Okay, does that kind of make sense how we do that? Okay, this is kind of a tricky one because of, you have to make sure you're at the charge the right way. You have to make sure that you're adding the right number of protons or electrons. Yes?
So use any like chemicals and just add or subtract.
Yeah. So if I pick like neon, what charge would neon have to have so that it would have 36 electrons? Yeah. You could, I'm not sure if Alex will let you do that. You can try it, see if Alex will accept that. Okay. All right, let's move to the next one. So chapter 3 is about ionic bonds. So we're going to talk about what that is. An ionic bond is a transfer of a valence electron from a metal to a non-metal to form a salt. So remember we talked about how electrons are always going to want 8 valence electrons. So what happens here is the metal gives away its valence electrons to the non-metal so that both of them have a full shell. So one becomes positively charged, one becomes negatively charged, and then we have this charge balance. So our metal is positively charged, our non-metal is negatively charged, and they match up. So that is what an ionic bond is. So this is like the valence electron gets stolen by the non-metal, and the metal loses its electron. Then we get positive and negative charge. So that any salt, when we talk about any type of salt, that's what's going on. So table salt does this, but the salt that you put on your sidewalk also does this. And then there's like a whole bunch of other salts that you will use during the labs. So we'll learn more about those. Okay, so an ionic compound forms between a metal and a non-metal. That's a key. If you can identify is it a metal or a non-metal, then you can figure out is it an ionic compound or not. And the key here is that the metal is losing the electrons and the non-metal is gaining the electrons from the metal. So that was basically on the last slide. But the key here is that we need to be able to use that ALEC table, the periodic table, and decide, is this element a metal? Is this element a non-metal? If we have a metal and a non-metal, then that's going to be an ionic compound. Yeah.
Is covalent compounds that extruded?
Yeah. We're going to talk very briefly today about covalent compounds so that you can distinguish them for chapter 3, but chapter 4 is about naming and knowing ionic compounds. Yep. Is it really hot? It feels like so hot. Or not?
I feel great.
You feel great? Okay. I just feel like it's so hot. I think that usually there's at least some air. And there's like no air moving in here. Okay, so here are some examples of ionic compounds. So we've got sodium and chloride, calcium and iodine, tin and chlorine, calcium and phosphorus. So if we look at all of these, the first element is a metal, the second element is a non-metal. So that's how we're going to be able to tell. Is it an ionic compound? Is the first one a metal? Is the second one a non-metal? If that's true, then it's an ionic compound. Okay. So here are some physical properties of an ionic compound. So just think table salt, that's probably the one that we are most familiar with. This is some of those properties. So they are crystalline. So what that means is this picture. We have a really well ordered, we have a positive metal and a negative non-metal, and they have to be right next to each other in some kind of crystal structure so that they charge balance. So this is what sodium chloride would look like. Its crystal structure. They have really high melting points and boiling points. So to get liquid salt to boil that takes really high temperature. When they dissolve in water, what we get is the particles of sodium and chlorine. They separate these different charged ions, and we get little chlorine atoms floating around in sodium. So it doesn't look like this crystal anymore. They separate into cations and anions. And so if we take salt and we put it in water, that increases the conductivity of water. So that's one way to detect if you have a salt. Because if you add salt to water, then your water will be conductive. like Sloan pointed out, chapter 4 is covalent bonds, but we're just going to briefly touch on that so that we know what to watch out for. When it asks us if it's ionic or covalent, this is what they're talking about if it's covalent. Or they also call it like molecular, something like that. Nonmetals are going to share electrons. So remember, nonmetals are above that kind of stairs and to the right. So upper right of the periodic table are the nonmetals. So if we only have nonmetals in our compound, that's going to be covalent. That's not going to be ionic. And we'll talk more about that in chapter 4. They're going to share their electrons to complete the octet. Remember, in ionic, the metal loses electrons and the nonmetal gains electrons. In a covalent bond, the nonmetals are going to share. And that's how they're going to get their full octet. Remember, that's what's driving bonding, is that everything wants to have a full shell. So the other thing to watch out for is that if it's a metalloid and a nonmetal, that's also going to be covalent. To be an ionic compound, it has to have a metal and a nonmetal. If there's a metalloid and a nonmetal, that's still considered covalent. So watch out for that. So I think that's the way you're going to distinguish if it's ionic. It has to have a metal. It has to have a nonmetal. All right, so here's another image of what a covalent bond is. If we have two hydrogens, they're going to share their valence electrons, and now they have the full octet. Hydrogen is also really small. It only wants 2 valence electrons. So if they both share their valence electrons, they'll have an octet, or they'll have their full shell. Fluorine, if we have 2 fluorines and they pair up their valence electrons, both of them will have a full octet. And that's why it's helpful to draw our single electrons by themselves, because that helps us, if we 2 electrons that pair together on a nonmetal, those electrons will be the bonding electrons. So that's why we draw them like that. Okay, so here's a meme. You have a joke about covalent bonds, do share. Ha ha ha, because covalent is sharing electrons. Okay. All right, so go through these and see if you can decide if they're ionic or if they're molecular. That's what Alex calls them. So molecular or covalent. I'll give you just 1 minute so that we don't take too much time.
So ionic. Second one. Carbon, oxygen. That's what I can CO2. That's ionic. Carbon, C4. Oh, wait, yeah. Wait. Why?
Okay, that's in about a minute. Are there any that you're getting stuck on that you want to go over? Okay, does that make sense? So I want to point out a few of them. So we've got this one. Is this one ionic or covalent or molecular? This one is covalent. This is molecular. Alex is going to call it molecular, which I don't understand. Good, because it's a metalloid and a nonmetal. So this would be molecular. Okay, not ionic. How about this one? This is ionic. Good. Okay. All right. So you guys feel pretty good about those? Okay. Maybe this one. How about this one? Good. Ionic. Metal and a non-metal. Okay. Good. So that's all you have to do. Make sure you find a metal and a non-metal for ionic. Okay. I just printed this sheet out for you, so you don't have to write it down. I will go get that. But we're going to talk about polyatomic ions, which are groups of charged ions, a group of atoms that is charged. So there is a list on Alex that I printed out for you that you will have to know for the test and for the final. So as we go through the year, you can either start memorizing them, or for this test especially, I would put it on my note card. But you can also, as we see them more and more, you'll start picking up on them. And so hopefully by the final you'll remember them, or you can also write it on your final note card. Okay, and so I printed you out this sheet so you don't have to write it down. So here are some ionic compounds that have polyatomic ions. So remember, polyatomic ion is just a group of ions, or a group of atoms that has a charge. So sodium bicarbonate is probably the most common one that's baking soda. You've used baking soda before, okay. Magnesium hydroxide is an ingredient in acids. Let's see.
Magnesium hydroxide.
Yeah, have you heard of that one? Magnesium hydroxide? Okay. Calcium carbonate, sodium hypochlorite. So these are all from consumer goods that we use. So we do come across polyatomic ions pretty commonly. They're pretty common. All right, so if we are including those, go ahead and see if these are ionic or molecular with your list. Let me grab you the list while I'm. So see if you can do it without this. I'll go grab the list.
I don't have it memorized like you do, Nathan. You type your table. Oh yeah, I know exactly how many neutrons is in Einsteinium. Exactly at the top of my head. I still can't find copper. Oh, it's on the top. Okay. So it's a metal and like two airs, right? Airs. Yeah. That's what I call them. Two airs. They're not like a metal, so it's two airs. Two non-metals. Okay, so it'd be ionic, right? Is it? The first one, CuPo.
All right. I forgot that I was supposed to print this out. So let me hand this to you. These are the ones that Alex is going to make you memorize. So these are not going to be in the Alex data.
Nitrogens and oxygens. So it'd be covalent.
Okay. So if it has a polyatomic ion and a metal, then that's going to be ionic. So even if it's all non-metals, if it has a polyatomic ion in it, then it's covalent. So yes, you either need to memorize it or write it on your note card.
Wait, you said it's polyatomic ion plus a non-metal? That's still ionic?
Yes, polyatomic ion plus a metal. Plus a metal. Did I say metal? Yeah. Will also be ionic. So basically anything is ionic if it's a charge and another charge. They're bonding because they're charged, not because they're sharing electrons. Okay. So how about this one? This is potassium permanganate. This is one of the ions, the polyatomic ions. So we've got potassium, which is a metal,
Yep.
and permanganate, which is a polyatomic ion. So this is ionic. Good. Okay, this one is kind of another tricky one. This is the acetate ion. So we've got potassium and acetate. This one is polyatomic. Okay. This one is like the anomaly that comes up.
So that's.
We have two polyatomic ions. We have ammonia. Ammonium and hydroxide. So this one is also ionic. This is ionic.
Oh my gosh, wait. Ammonia,
Even if there's no.
Yep, even if there's no metal, because we have two pieces that are charged, ammonium and hydroxide. Okay, does that make sense? Do you want to go through a few more, or are we okay? A few more? Okay.
Yeah.
All right, how about
Al2.
Al2CO3? Do we've got a polyatomic ion? Yes. And we have a metal. Metal polyatomic ion. This will be ionic. Good. Good, this is carbonate. Good. How about this one?
That one.
Whoa, I didn't know I could do that. This one is molecular. This doesn't have a polyatomic ion. It's all non-metals. That's molecular.
So if it has a polyatomic ion and a non-metal, then what is it?
Then it will be. I don't think there's. It'll probably be molecular.
Yep.
Yes.
Will there only be a few that are like different than ammonium?
Yes. Yeah. This is an exception. Yes. This is the big exception.
Okay.
Yep.
Permanganate.
But like those ones are weird and then you just have to look for metal.
That one's weird, and then otherwise you have to look for metal. Yes. Good. Good. That's a good strategy. Okay, let's move to the next thing. Oh, except that's the last thing. Okay. Questions.
The Alex periodic table is not working.
It is not?
Yeah, when you try to compare it, it tells you that something's not working, and then like you have to go all the way back to numbers.
Okay. Is that happening to other people too? Yesterday, the questions weren't working for the people who were taking the test yesterday. It was like, wouldn't load the question. So they had to like close all their browsers and restart their browser. And then the one person had to shut their whole Chromebook down and restart. So you could try that.
Yeah, I'll try that.
But yeah, I don't know. Yeah, Alex was being super weird yesterday.
Like,
And that might have carried over to the
it might
periodic
start
table.
working, so just like, as long as I like don't click it and look up there, I'm fine.
Okay. But yeah, you need it for the test. So maybe between now and the next test, make sure you like restarted your computer. But it's probably on Alex's end.